Hello, this is Daniel Magin from Frankfurt.
And this is Daniel Wolf from Hamburg. Hello.
Hey Daniel. Today we want to talk about using Apple instruments to performance tune your iOS application.
Yeah, especially we are talking about Delphi for iOS applications.
Correct. So let's talk about what is instruments and how to get it, how to find it on your computer, on instruments basic concepts.
Okay, let's start with the first question. What is instruments? Instruments is a tool that comes as part of Xcode, which is the most important development tool for the Mac and iOS platform. Would you agree?
Yeah, absolutely. So the after installing Delphi XE4 and you want to develop software for iOS, so you have to install minimum the Xcode command line tools, but there's no instruments included. So you have to go in the App Store, in the Apple App Store, and download for free the full Xcode stuff, and then you consume automatic the instruments application on your machine. And this is the way how you get it. So do not install only the command line tools, you have to install the complete Xcode package.
Absolute. It's a big download, but it's worth.
Yeah, and so after this you have not only the Xcode and instruments, you have a lot of stuff around that, and so you in my opinion it's really the best way to do that. Delphi XE4, if you compile later over the PA server to the Mac side, you see it in a lot of other videos, and the PA server is giving to Xcode command line tools the stuff, for example, for code signing and all the other stuff that's on the Mac side. This is the reason why you need a Mac to develop iOS application. So how
I really hated to interrupt you, but we have a big typo on the slide. Hot to find it on your computer.
Yeah, that's no problem. We can very simple change that. How to find it on your computer?
Sounds like quite a silly question. How do you find an app on your computer? You go to the application folder and start it. It's pretty simple. But you won't find instruments there. You will find Xcode, but you will not find instruments.
Correct. So how you can start instruments without Xcode?
It's pretty easy. Just use a Spotlight, which is the small search icon in your menu bar, on the top right. Exactly. This is the fastest way to start instruments. As an Xcode developer, you could start it from within the Xcode IDE, but as a Delphi developer, you will just use Spotlight.
Okay, let's talk about the instruments basic concepts before we start live in action how instruments is working. So if you start instruments the application, then you get different templates, and they give you, let's talk about sensors later, what is a sensor, but you get a lot of stuff. Now Daniel, I found on the left and on the right side a lot of icons. What is it?
Okay, let's start on the left side, which is easier. You will see the headers, iOS, down there iOS Simulator, OS X. These are the different platforms you can use for instruments.
Correct.
Or
so
the other way around, instruments can analyze and instrument applications on these platforms. So this is quite interesting. Today we are just talking about iOS, but you can use the same instruments also for your OS X applications.
Correct. With Delphi XE4 you can create Mac applications, and so you can search with instruments for memory leaks or allocations or battery. Yeah, why not? If you work on a MacBook Pro or whatever.
Of course, yes.
Yeah, to see which code is using some more stuff. On the right side, you see a lot of templates. So you can, in these templates, consume pre-installed sensors. So there you see later there's a couple of sensors, a lot of, and with these templates you see very easy, okay, which sensors I need for memory leaks, of a time profiler, of a zombies. So or you can use blank and per drag and drop. You see in the live demo add your own sensor stuff and so on. So you see there's a couple stuff of that. And also you see here there are other sensors for system usage, core animation, for the graphic stuff, and energy diagnostics. And so it's very easy if you're very new in using instruments. You see, for example, what I need for sensors for network analyzing. So it's very easy to select this template, and you have all the necessary sensors together for your stuff. Very important is on the left side, if you are analyzing your application on your device or if you're analyzing on your iOS simulator, because there are different compilations. One is for the Intel processor, and the other is for the built-in A5 processor or whatever in your iOS device. So there are different types of application compilations. So be absolutely see what kind of device you are analyzing. It's a simulator or it's a real device. Okay, so I would just
Yep. Before we jump into the project, you see from the amount of templates you can analyze every single bit of your application. And the fun part is you don't have to learn everything new. So if you understand how one template works, you already know how all the other templates work, because basically they work all in the same way. That's the reason why we won't show each and every template in this session. It's enough to show 2 or 3 templates and you get the idea. And that's enough for you to start your own work, to play around with it and to collect your own ideas and information.
Okay, what is Apple Instruments?
Apple Instruments is part of Xcode. Xcode, the most important development tool on the Mac side. Apple Instruments is an analyzer. It allows you to inspect a running instance of your app on the device. So basically the same what the traditional tools like Task Manager or Process Explorer on the Windows platform were.
The most important thing is that Instruments is not a debugger. Instruments helps you to analyze your, for example, how your graphic is working, the memory, who is responsible for memory leaks, you can analyze how many objects allocated and so on, your memory usage. You can see who is responsible for energy, which sensors are running, the display light and so on, network traffic. So you can analyze everything. Okay, we have prepared here an application. It's a stupid non-profit application, but we have here some issues implemented to help to show how you can analyze with the Instruments application a Delphi for iOS application. On this tab control you see, and that's Reflector what he's running. You see it really live my screen for my iPhone, for my real device, hardware device, and I have here cool rotating Delphi helmets. And in this application, we want to show how your core graphic API, what's going on. On the second screen, we have here some couple of buttons.
Yes, on the second screen, we want to analyze the memory usage of our application. So we allocate memory, more and more memory, we free the memory, and we want to analyze live on the device how our application behaves.
So we have here in this button memory test Arc. Arc is a new memory architecture which comes with the iOS operating system, and it's an automatic reference count architecture. So you have nothing to do anymore with how to free an object. So if it's 0, or no pointer is assigning anymore to this object, it's like a garbage collector. It's automatic destroys the object. But about Arc, we are creating, I think, a separate movie because
Absolutely,
Arc, it's too complex to explain in 5 minutes. On this button, we have here a variable in the procedure, an object list of objects. Then we have a show message step in procedure. We create this object list and adding 10,000 of objects, and then we are leaving this procedure. And then we are seeing later that all these objects are destroyed because on this variable is no pointer anymore looking to this variable. Okay. On the second button.
The second button, it's quite a similar code. We are also creating a list, and we are populating the list with 10,000 of objects. But the difference is the list itself is part of the form. So the list object itself stays alive. So it won't be freed by the automatic reference counting after leaving the procedure.
So the free button, then we are releasing all the objects in this T list. It's not a T object list, so we have to do it by hand. And then we are freeing the list container.
This is quite the classic programming style, creating an object, using it and freeing it by hand.
Yeah. Then we have a third button. It's called Eat Memory, and you see here we have here Memory Monster.
It's fantastic, a memory monster. Memory monster itself is also just a list containing to the form. We are creating the list in the form create event. It's standard so far. And then in the on-click event of the button, we are... Can you show us the on-click event,
okay,
please?
Here's the creator. Okay.
Oh, yes.
From
Okay.
the constructor. Okay, and...
Here. We have declared a variable to t bytes, and we set it to a length of 50 megabytes, and adding this to the list. So each time we are clicking the button, we occupy more 50 megabytes more of memory. So if you click 10 times on the button, we occupy 500 megabytes of memory.
Yeah, that's a memory monster. Okay, on the third screen we have here network, and behind here is a web browser component, browser component, and we are doing here on this toolbar button nothing else as loading in the web browser URL youtube.com and to analyze later network graphic. Okay, on the GPS sensor side it's very similar.
It's quite standard. We have a T-sensor location component, and we are querying the hardware sensors of the device using that component. So, as you can see, we are working on very different technical areas of the device, and all of them will be analyzed using the instruments software.
Okay, so first I would say let's start instruments.
Yes.
With instruments, when you start this is coming with Xcode. So you have to install not only the command line tools of Xcode, you have to install over the App Store. If you go under the Apple menu, there's an App Store icon, and you can download for free the Xcode installation kit. And it's downloading and installing. Then instruments is included in your on your machine, and then you can start this. Okay, instruments have, if you start this and create a new project, you get here some couple of different what you like to do. It's instruments iOS simulator, the Mac OS X, or what we do is here direct on the iOS device. If you create a blank project, then you have here library, and you can very easy by drag and drop add to the analyze whatever which kind you want to inspect, the Wi-Fi network in battery, the memory monitor, or whatever. For example, the connections or Bluetooth or CPU. Interesting is also that you can type in here the CPU. And you can see CPU monitor or how the CPU is working with your battery and so on.
Just to make this clear, we are not talking about the CPU of your computer. We are talking about the CPU of your smartphone.
Correct. So there's also here some really cool templates. So let's start with the OpenGL, with the core animation. I would suggest you see here that's a nice small template fixed. So you can go here to my iPhone, and we want not to analyze everything which is running on the iPhone. What we like to do is with choose target, you see all your applications which is installed on your iPhone. I have a couple of applications on my iPhone.
Really a huge list.
Yeah, and here is the product, the FM Analyze. That's the program what we have done. So let me bring some couple stuffs together. That let me close the reflector and restart reflector again. That's here on the same screen, and that you can see what I'm doing. So I bring here AirPlay, perfect. So
this is a live view from your device.
Yeah, correct. So I start now over the instruments, the application on my device, and now I start the animation. That's that was not the core animation what we need. So we need the OpenGL driver. You can also add on the library some other whatever. Some other OpenGLs, or not only the driver, the analyzer, or whatever you can add, or as a CPU monitor. That's very simple to do here. For example, I want to add the CPU monitor to see what's also going on. So we go here to the FM Analyze and press again the record button.
So we start the application by pressing the button in instruments, not on the device.
Correct. So let me bring, so now I switch here the switch, and you see now what's going on. And you see that with rotating, so I bring switch off. So you see it's going down, and I can also switch on. And interesting is how what is coming if I bring the application in the background mode. And you see it's really going down. If I go back, wonderful, it's working. And also if I go to this tab sheet, you see the FireMonkey Framework is not rotating anymore the helmets, and now it must be coming up. You see also in the time profile the information, and in the CPU monitor. So I can stop now the recording, and you can see now here with this you can go in here and see everything in percentage, what's going on. You see here the time profile. You can go to the CPU monitor. You get the information, which processes are running, and so on. You can parent-child samples and so on. And also here on the OpenGL, you see here really how many animations per second was done during this time. So if I go here, and yeah, that's very simple. And also you see here some really cool marks here. You see that here the program is go in the suspended mode in the background, and here is coming in the foreground. That's really interesting. For the instruments is a really big documentation on developerapple.com to learn much more about this tool. Okay, let's go to the memory.
Yeah, so in the program we want to switch to the second tab soon. We have to prepare our panel. Daniel will add some memory.
The allocations.
Some memory sensors.
Yeah, this song is enough, I think. So that
should be good, yes.
There are a lot of more memory sensors, like the stuff for memory leaks and so on. So let's start to record this application. Now the starting needs much more time because it depends from the sensors what you are using. So we go now to the memory, and perhaps you can remember that here when I press the memory arc that this 10,000 objects will create it after I pressed this step in procedure. Let me bring back very quick the code. Perhaps you remember that we have here in the button one click. Here we are creating the stuff, and then we are leaving, and then all the objects must be destroyed. So I press. The interesting values are live bytes and living. Live bytes, Daniel, we have this memory which is allocated.
Yeah, this is kind of a basic memory usage of our application.
The living objects are how many objects are created in the memory.
Yes, but in this term it's not the object. This is the memory manager speaking, and he speaks about objects in memory.
Yeah, that's much more than not only the application and so on. So, but remember, when I press now here the OK button on my message box, then 10,000 you see on living that I have now 120,000 objects. I leave it now, and you see it was falling down. And also the memory works perfect. The next was the 10,000 objects we created in the T list, which are running in the form. So it's created. You see memory is going a little bit up, also the living, and now we are free the objects, and you see in the living and the bytes, I repeat, and free. Now we have the memory monster. Danny, should we try out?
Yes, press the button once, please.
Got it.
So we allocated 50 megabytes of memory in one step. So you see it in the chart, it's a huge step. We should have made the other objects a little bit larger to, just to visualize the 10,000s of objects, but don't care. So look at the column live bytes. So now we have a memory footprint of 175 megabytes.
So press again each memory, and you see now we have 225.
It's not that surprising.
So, and if I press and press...
It's so funny, press and press and press.
Isn't it amazing what my iPhone can eat?
Yes, you have a very strange iPhone. So we could play this game forever.
And now it's crashed.
We cannot play this game forever. So, was our application invalid?
Good question.
Does it have an error?
No, we eat too much memory. So what's really behind? If you go in Xcode, and in Xcode you have a tool, it's called, in the window, it's the organizer. Let me bring it up. And where is my iPhone? This is my iPhone. Okay, have to read some stuff. Button. Got it. And now we have here console. I will clear now my console. Here you can see everything what the iPhone is sending an information like a log file.
Which is quite a lot.
Yeah. So let's start the application. So that's the application.
So the most part of this log file from your iPhone will be uninteresting for you.
So what I do now the monitor, okay, this is not the important, this one here, the reflector stuff. So what I do now is I'm pressing now the eat memory button. Once, twice, third.
You see it on the chart. Your program is consuming memory.
5. Let me clear 6 times, 7, 8, 9, 10, 11. So now you see that the iOS operating system is sending you a received memory warning. That means the iOS operating system, AK baby, if you eat more memory you have to release, I will kill you. And I press again eat memory, and you see a couple of exceptions coming up because the iOS operating system is killing your application now because you eat too much memory. So look, how to handle that?
It's a tough life for an application on a device, isn't it?
Yeah, it's a small, it's only a small computer. So this memory warning then is coming in my application, isn't it?
Yes, the warning itself is sent from the iOS operating system to your application, and it's called an application event, and we can register a handler for these events. You see there are different kind of events, and one of these events is low memory. And as you can see, in this case we got 3 warnings. Normally you get 2 warnings or at least 1 warning, and then you will have to do something. You have to free some memory. Not necessarily your main business objects, but you could free some caches. You could free...
Yeah, clean up your room.
Clean up your room, exactly. Things you don't need anymore.
Okay, this application event handler, we got it here. And what we do is we clear the memory monster, all these MBs away, so we have in a cool thing the that's behind. So let me go also in debug mode, so we can or let me go one step back. What we have here in the memory, in the allocations, you see here there's a lot of stuff, but we cannot read anything about that, and so because we have no debug code inside. So
what we see here is the call stack.
Yeah.
It's nice to see that your application has allocated lots and lots of memory, but sometimes you just don't know why and where this happens. So you start lurking down in the call stack.
Yeah.
Right now we just have the code addresses.
Yes, you see here the code addresses. If I go in, and you see nothing what's really behind, and that's really not very explaining what's coming up and so on. So what we are doing in our Delphi code is we go to debug, and let me run the PA server so I can deploy this application again with debug mode. So I will compile now the application. Okay, so let me bring up here again that's the application. Okay, but I have to run it from
Instruments.
Yeah. So what we have now with the debug code, Danny?
So basically we did the same thing we did in earlier times, just normal Delphi. So if you want to see useful information in the call stack, you have to generate the debug information.
Okay. So I go now to eat my memory, and eat and eat and eat and eat, 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 eat. And you see now it's down because we received this memory warning, and we was cleaning up the cookie monster.
Now you could play this game forever, really.
Are you sure?
Absolutely.
Do you see these flags here on the top? And this is the memory warning flag.
Yes, but our application responded to it.
Correct.
And freed some memory.
I can create really cool buildings with my memory here. No. Okay.
You're an artist.
Yeah. Okay, so let's go to the next one. Let's go here in the debug code. So if we go on the object list, you see here much more information now what's behind.
And the fun part is we are using the Apple software to instrument Delphi for iOS application using the Delphi for iOS debug information. So as you can see, we have really standard compliant debug information here. So the Apple software is able to read this information.
Yeah, you see here the FMX, FireMonkey Framework, you see here T-Control, mouse up or whatever, you can read out everything. Okay, so let's go to the next tab. And so the third tab what we have was the analyzing of the network. Let's play a little bit with that. So if we go here to the network stuff, and it's a so we're starting again the process on my FM analyze and start record, and so we go to the network tab and say refresh, and we are reading YouTube. So we stop the application to see what's really now behind. Is you see here different processes, but I want to see the connections where all my iPhone is connecting out. So you can really analyze each application which is on your iPhone, who is calling home. And you see, for example, here my FM analyze, my FM remote. So let's look here, for example. There is one address, and the cool thing is to analyze how it works. Let me go to, I need this on this side. If you say, for example, ping, it is fa-in-f91.e1e100.net. You see here IP address. Let me copy this IP address and let's look who is that, who is. And you see that's from Google, because YouTube is running on Google. You can really find out who is connect and so on. You can also see on the connection the interfaces, what is used, the Wi-Fi or loopback adapter or the 3G, 4G network and so on. So there are different couple of aspects what you can do. Okay, and the last one was the sensors. That was also cool. Daniel, what we can do there?
Well, accessing the sensors has, of course, impact to CPU activity, to energy usage, to...
So, analyze. Let me bring up. So you see here the energy uses, you can add also CPU uses and so on. You see the GPS is not active. So if I bring now active the GPS, you see now with red that my GPS is on and my GPS is off. And something also, brightness of the screen. If I go now to my settings and say here the, let me bring with, that's German. So the brightness, you see the brightness also on this bar here. You see it's going up, down. For example, Passbook, this application where your tickets are in. If you go to Passbook, did I have? Yeah, I have one here. And if I press oh yeah, I'm playing now with that. The brightness. Now, how was it? I don't remember anymore. But normally the brightness is going up and it's down and so on. So you can here really analyze the network activity, the display prices, sleep wake, Bluetooth, Wi-Fi, GPS on the aspect of your energy. And there's a lot of, in the library, a lot of other sensors about the energy also. And now you can mix a combination from your library of sensor, CPU, monitor, brightness, or whatever, disk monitor, read and write from the iPhone and so on. So you can analyze each aspect what you like.
So this is a very powerful instrument in the real meaning of its word. and you can use it together with Delphi for iOS, which is very important and very good.
Okie dokie, so we got it. This was a small introduction about Delphi iOS and instruments. You see, it works perfect. Yeah, this was a cool demonstration about the instruments stuff. So before we go to the Q&A stuff, the instruments video is existing some couple of weeks in YouTube, and so we get a lot of questions before. So let's talk about the most important questions what we received before the CodeRage about the video. One is about the debugs DCUs, Daniel, correct?
Yes, absolutely. As any other debugger or analyze tool, the first thing you have to do is to compile your application, including the debug information. It's getting bigger and bigger, but it has to be this way, because otherwise you won't see any understandable information. You will just see memory addresses. If you are keen enough to read memory addresses, you will be satisfied, but most of us won't be. So compile your application with the debug code. And then there's another option in the Delphi compiler settings for your project. You can include or exclude the debug DCUs of the VCL or RTL. So if you just want to analyze your own business code, you can happily exclude the debug DCUs from the VCL or the FireMonkey Framework, because you don't want to see all that stuff. It's just too much on the screen. So my advice would be just exclude the debug DCUs if you don't want to analyze the FireMonkey Framework.
Yeah, the cool thing is then you see only your code stuff and your stuff, what you have written in source. And this is the most important. So that's a cool thing. So should we show also the other stuff in instruments to display in height in the stuff in instruments to do that? So we switch
Absolutely.
to. So I would suggest, let me switch to your computer. Okay.
Okay, I have prepared a very last example. It's a small application consuming memory. We've seen this before. And I just want to show you how to deal with the call stack. Just let me record a couple of things. You don't see the application itself, but it's not that important right now. I'm just pressing a button here and stop the recording. So what we see here is a system call of malloc, which allocates 50 megabytes of memory. The first thing I can do is just to press the little arrow here, and I can see in the very last column responsible caller, which is, let me enlarge this, my memory monster, and oops, oh, now it's gone. No, come back. My memory monster, which is the constructor of my class. So this is the first very useful information. Another useful information is the column live, which means that the object is still alive in memory and hasn't been cleared or freed from memory.
Yeah. Hmm?
So this could be a reason for getting a memory warning or whatever. Now let me switch to the call tree.
Okay, now we have here the call tree of your application.
Which is useful, a very good information. So let's exclude this, and it looks nasty, really.
Yeah, a lot of memory numbers, that's crazy.
Oh, look, they're all 93. This is usually a problem. Okay, here on the left, we can configure the call tree. And the first thing I do is to hide the missing symbols. In other words, to hide all the symbols that have only memory addresses. So this looks a little bit nicer, but I can also say hide system libraries, because I don't want to debug into the iOS framework itself. So now we have quite a small call tree, which is quite nice. And here you can see very useful information. I do have a tform3 containing a button consume memory. It has an event handler, consume memory click.
Yeah, that's very interesting, because you can focus your search on the main stuff of your code, and you have not to look and in all the other call tree stacks from the missing symbols and the system libraries, so you can concentrate on the stuff what you really need to see. Okay, so
okay, we got a little interruption.
Yeah,
from Hamburg to Frankfurt.
Okay. I used the time to talk about that, so you can concentrate. I repeated that you can concentrate the stuff on your code and so on.
Okay, that was what I wanted to show. Very important options on the left: hide missing symbols and hide system libraries.
Okay, so there's one interesting thing to know about instruments also, where some problems can come, Daniel.
Yes, and they are in conjunction with the PA server. The PA server, when it deploys an application to your device, holds some references to that application. You have to quit the PA server before you can start using instruments, because sometimes there are conflicts.
Yeah, there's coming a message on instruments you cannot analyze, so stop the PA server, and then you can analyze and then restart the PA server from the terminal window. It's very easy, I think.
It's pretty easy, you just have to know this.
Okay, so first, before we go to Q&A now with your questions, we have to say thank you for listening this instruments demonstration, and I hope you learned a lot of, and now we are open for any questions.
Yeah.
Yes, the question was, what's the difference between allocations and leaks profiler? Actually, they have a different kind of perspective. The allocation profiler just counts how many bytes of memory your application consumes, without asking the question whether you free the memory or not. The leaks profiler concentrates on the question if you really free the memory again. So it's the same area but different questions. Okay. Then we have a question, or for information, OS X Mountain Lion has a lot of more instruments. Yes, because there are other sensors, because the full operating system have much more available for some stuff. So it depends from the device. So we have different sensors. This is what we talked in the beginning. On the left side of instruments, you have different sections, what you want to analyze, your simulator, your iOS stuff, and so on. Okay.
And Stuart had sort of three, sort of in a row, he asked about allocation memory failing, and then he asked, he meant what would happen program, and then he said you answered it, but maybe take the three together.
When you get an exception, typical Delphi exception, the device is not showing the exception, it crashes the application direct. Perhaps if you put a try except code around the code where the exception is coming, then you can show you have to handle each exception. If you're not handling the exception, the application on the iOS device is crashing. So if the memory is failing to allocate, you get exception, and if you don't handle that, the application is kicking out of the iOS operating system. But this has something to do with Apple, not with Embarcadero or something else.
It happens with all iOS apps, right? So they just go away.
Correct. It's the same if you write your application with Objective-C and you don't handle that, it's kicked out.
And you can use Xcode, and when you go to the organizer window and you click the device, there's these logs that you can see, the crash logs show up.
Yeah, when I develop with FireMonkey iOS applications, I use with Xcode, you can say the organizer, you see the crash logs, and the console, you see a lot of stuff. That's the same what we showed in the video with the memory warning with this console, and so you see a lot of things. So this is running every time on a second screen during developing more stuff. Okay. There's information instruments is starting with Xcode 4.6.2. The version number is now in the Open Developer Tools, so you can download or start separately. Okay. That's a question. Do you have to close down the app on the iPhone or just put it in the background before starting instruments? You have to stop because the the instruments is starting the iOS application you want to analyze. If it's running in the background, it doesn't matter. You have not to close. Instruments is restarting the iOS application. You have not manually stopped, but Instruments is stopping the process task. That's great, wonderful for the flowers. What are the advantages of analyzing the display brightness? That's very simple. Some applications, for example, the German railway application, if you show your ticket to the barcode scanner of the person who's controlling your tickets, the brightness is coming from the application direct to full power. So you can see if it works, if you want to give brightness more power or less. I don't know the English word, to make it darker or much more this or that. So you can control it. In parallel, you can see more brightness needs more battery. So if you're manipulating the brightness from your application to show barcodes or whatever, then it's a cool thing. If not, if you don't display brightness and manipulating, it doesn't matter. And there's a German thank you.
I think next question is how to profile a Delphi app in the iOS simulator.
Okay.
Actually, same way, just choose not the device, choose the simulator on the left in the list of the templates. It's basically the same process.
Correct.
You just have to start the simulator before starting Instruments, because these two applications do have to know each other.
Correct. Can I make calls to Instruments from Delphi code, for example, for tracing purposes? I think not. I'm not sure. I didn't try it out. There's a Daniel. You have a website with a wonderful documentation of Xcode. Perhaps you can post it. Perhaps you can find something. There's a Objective-C header file or whatever you have to implement, but I don't know.
So just let me paste this link. So this is a link to the Apple developer site explaining all these templates and different sensors you can use.
Quick question, when you try to build a release version, do you see any performance enhancements in Instruments? As we know, Debug is larger app. Yes, you can do it, but you don't see in Instruments the FireMonkey class names and so on. You have only the numbers of the memory stuff, but you can full, with your release, you can performance.
You can analyze it.
Yeah. With the upcoming Android integration, there's a similar tool. We don't know because Android is not here now, so I have not to answer that.
Actually, it's about the Android SDK in general, if it contains a tool like Instruments. To be honest, I just don't know yet.
Okay. I find the graph for memory allocation kind of useless, as the memory allocation increases by graph scales down, but there's no vertical axis to show the scaling.
Actually, you can scale the graph. So
yeah, you use the mouse and only make by you select the time frame. It's important. Then it's zooming up and down.
On the left side on the instrument screen, there's a little Pömpel, as we say in Germany, and then you can adjust the zoom factor.
Yeah. Okay. Great source for the information. Okay. I have 3 more forms. It's memory how to act in the app event inform all firms created. Did you understand the question from Frank Lauter?
If you have 3 or more forms with memory monsters, how do you react in the app event and inform all forms? Actually, it's a in Delphi question. So you have one handler for your application events.
Yeah. Mm-hmm.
And within this handler, you have to go to your forms and to do something. Something means to do whatever you have to do to free some memory. So this is a question that is very hard to answer in general.
Yeah,
you have one single point, one single handler that gets your application message. In this case, the memory warning. And now it's up to you to do something meaningful.
Yeah. What is the best help reference for instruments? That's the URL from Daniel, what we published. Then I thought XE4 didn't require to use Xcode. I'm misunderstanding. No, if you install Delphi XE4, then you need a Mac to also. And normally you only need the Xcode command line tools. But if you like to use instruments and so on, then you have to install Xcode, the full version. You have not to do that, but the Xcode command line tools you need. Okay, thank you, thanks, and again, thanks.
Looks like lots of thanks.
Yeah, okay, that's all. So all questions are done.
We're also at time, but
yes.
Again, Daniel, could you post in Ernest the best help, the URL again in Ernest Orr's 6:57 a.m. question?
Yes, of course.
Great, thanks. Just so it's in the log twice.
Yeah.
Yeah. So send. So it should
Great.
appear.
Let's see. Yes, absolutely great. Oh, that's a big long URL. Well,
Yeah, on the left side on this website, you have a detailed information about each sensor. That's really interesting to read about that.
Delphi Taga 2013. That's in Leipzig.
Yeah.
It's
There we
nice
go.
green.
Leipzig.
Yeah.
Lime green. And then Delphi experts. What do I put? Delphi expert? No, sorry, developer expert.
Yeah, both are working. Delphi experts and developer experts.net
If I
or
do
.com or
that,
whatever.
there you go. Okay.
Yeah.
So if you guys need more information, if you need help, you need training, consulting, all things Delphi, iOS, iPad, this is the website, developer-experts.net or Delphi Experts. All gets the same place.
We have an office in
guys,
Germany and in the US. And so
and then Olaf in Florida.
Yeah.
And you guys, I'll see you in Leipzig.
Yeah, I hope to see you. Thanks, David.
Yeah, you guys are great. Thanks very much.